Hey everyone, in this lesson we're going to look at rationalizing denominators and the numerators of radical expressions. Sometimes it's important to not have the radical in the denominator or the numerator for various reasons. So what we do is we do this process called rationalizing. So to rationalize the denominator in letter A, we want to remove the square root of 5 in the denominator. So in order to do that, we're going to just multiply by the number 1 in disguise. So I'm going to multiply by the square root of 5 over the square root of 5, because that essentially equals 1. And if I multiply root 5 times root 5, that's going to equal the square root of 5 times 5 if I apply my product property, which is the square root of 25, which just simplifies to 5. So the denominator doesn't contain the radical anymore, but you're not really changing the expression, you're just changing its form. So what I'm going to do is multiply two fractions, so just go straight across. Root 5 times root 5, as we said, is just the square root of 25, which is just 5. And then in the numerator, if I multiply 2 times root 5, I just get 2 root 5. I can't combine those because the 5 is under a radical and the 2 is a whole number, so we just put them right next to each other. Okay, kind of like in letter B, how you have the 2 root 16 next to each other, although you can simplify that. In letter B, I want to do the same thing. I want to rationalize and I want to remove the square root of 9x in the denominator. So think about what I would need to multiply by. And it is the square root of 9x. So we're just multiplying by the denominator, top and bottom, because that really just equals 1. And now I'm just going to go straight across. So when I go straight across, I have 2, and I'm going to apply my product property to multiply the square root of 16 times the square root of 9x, and I'm just going to leave it like that for a second. And the square root of 9x times the square root of 9x is really just the square root of 81x squared, and the square root of 81 is 9, and the square root of x squared is x. So see, the radical went away. In the numerator, we know that the square root of 16 is 4, so I'm going to put that 4 out there with the 2. And I know the square root of 9 is 3, so I'm going to put that out there with the 2 and the 4. And we can't take the square root of x, so we would just leave that inside the radical. And then all I need to do is multiply 2 times 4 times 3, which gives us 24, and then times the square root of x over 9x. And remember, you can't cancel the x's out because this is not x, it's the square root of x. So they're not the same variable. In letter C, I'm looking for the cubed root of 1/2. So the first thing I would try to do is I would try to split it up into the cubed root of 1 and the cubed root of 2. And see if you can use your quotient property to reduce that. Okay, so you can take the cube root of 1, it's just 1, but you can't take the cube root of 2. So I need to be creative here, and I need to multiply by a cube root because I can't multiply two roots together if they're not the same index. So think of that as 2 to the first. I need a group of 3 2's. So I'm going to multiply this by 2 to the second, because 2 to the first times 2 to the second is 2 to the third. So that would give me my 3 2's. And I need to do the same thing here. And then I'm just going to simplify. So I have cubed roots that I'm multiplying. I can just combine them. So 1 times 2 squared just gives me 4. So I have the cube root of 4. And you can't take the cube root of 4, which is fine. And in the denominator, I have the cube root of 2 to the first times the cubed root of 2 to the second. Okay, let's write that first. So 2 to the first times 2 to the second. Remember, this just means I need a group of 3 2's, which I have because 2 to the first times 2 to the second really is just 2 to the third. So the cubed root of 2 to the third is just 2. So I have here the cubed root of 4 over 2, and that's my final answer. Okay. Here's some more examples. So again, I'm going to split this. And we don't want the radical in the denominator. So what would I need to multiply by? And if you said the square root of 3y over the square root of 3y, you'd be correct. Because in the denominator, if we take care of that first, the square root of 3y times the square root of 3y is just 3y. In the numerator, I can multiply the two square roots together. So 7 times 3 gives me 21, and then I just attach the xy onto it. In letter B, I have two fourth roots, okay? And we're gonna look to see first, can we take the fourth root of any of those terms? So I can take the fourth root of 81, which is 3, because 3 to the fourth is 81. I can take the fourth root of y to the fifth. It would leave me with y, and then there's gonna be a remainder of y inside. So what I need to do is I need to get rid of this fourth root of y. So I'm going to multiply by the fourth root of y to the third. Okay, y to the third, because I have 3 y's and another y gives me 4 y's. So I'll be able to pull the y out of there. So now in the numerator, we're just gonna multiply straight across, and I have the same index, so I can just combine them into the fourth root of xy squared. And then over, I have 3y times, so this part is just going to give me y, because it's the fourth root of y to the fourth, which is just y. And then I wouldn't leave that like that. My answer would be the fourth root of xy squared over 3y squared. And remember, again, you can't cancel the y squareds because this is under a radical. So that would be your final answer. Okay. Oh, and that should be y, the top one should be y cubed. Sorry, that's a 3 right here. And I just realized that. So that should just be cubed. And this should be 2. Okay. So one of the important techniques that we use when we are rationalizing is we use this concept of conjugates. You've seen conjugates before when we looked at multiplying a sum and a difference of two binomials. We ended up getting a squared minus b squared if you were to FOIL this. Okay, we call this a sum and a difference. And these two are called conjugates because they're opposite signs of each other, and when you multiply them, the middle terms will cancel. So what I mean by that is if I was to multiply a times a, that gives you your a squared. But when you multiply the outer terms, a times negative b, you get negative ab, and then the inner terms would give you positive ab. They're going to cancel. That's why in this expression you don't see any ab's left. And then b times b gives you your b squared. So that technique will allow us to remove radicals when you have an expression that looks like this. So there's a radical and then plus or minus a number. Okay, here's a radical minus another radical. So to remove it, I'm going to multiply by the conjugate. So to find the conjugate, all I'm going to do is just change the sign. So it's 3 root 2 plus 4. I'm just going to make it 3 root 2 minus 4. So it was a sum, now it's a difference. And then I'm going to multiply. So in the top, I'm going to need to use the distributive property. 2 times 3 root 2 would give me 6 root 2. And 2 times negative 4 gives us negative 8. And in the denominator, I'm going to either, you can use this formula here. It's just going to be the square of the first term minus the square of the second term. So the square of the first term minus the square of the second. Or you can FOIL and actually see how the middle terms will cancel. But I'm going to use the shortcut. So all I need to do here is just take the a term, which is 3 root 2, and square it, and then put a minus sign, and then do 4 squared. So in the top, I still have 6 root 2 minus 8. And in the bottom, when you square 3 root 2, remember you have a product to a power. You have to raise each of these terms to a power. So I have to do 3 squared, which gives me 9. And then I'm also doing the square root of 2 squared. So 3 squared is 9. The square root of 2 squared is just 2. And then I have minus 4 squared, which is 16. So really what I have is 6 root 2 minus 8 over, and then I have 18 minus 16, which is 2. And you can simplify this. 6 divided by 2 is 3 root 2, and 8 divided by 2 is 4. So your final answer is 3 root 2 minus 4. For letter B, I'm going to multiply by the conjugate because I have a denominator with 2 terms and it's a difference. So I'm going to multiply by the sum. So I would have the square root of 5 plus the square root of 3 divided by the square root of 5 plus the square root of 3. And then to multiply, we're going to actually use FOIL for the numerator. So I would have my first times first, root 6 times root 5, which is root 30. And then I would do root 6 times root 3, which gives me root 18. And then I have the inner terms, 2 times root 5 is 2 root 5. And then the last terms, 2 times root 3 is just 2 root 3. And then I'm going to divide by, again, take the a term, square it, minus the b term squared. In the numerator, I'm going to go through and look to see if I can simplify anything. And there is nothing that I would be able to combine. Even if I simplified the square root of 18, the square root of 18 is 3 root 2, and I can't combine that. There's no other like radicals. So I'm just going to leave the numerator as messy as it is. I'm just going to leave it the way it is. And the denominator, though, I will simplify that. So if I square the square root of 5, I just get 5. And if I square the square root of 3, I just get 3. And of course, 5 minus 3 equals 2. So I'm just going to put a 2 there rather than rewrite that answer there. So definitely practice these. Take your time with them. When you get to the conjugates, there's places you can make mistakes when you're multiplying. So just take it slow. The only other thing we need to look at here is it's not as often that we do this, but sometimes it's helpful to rationalize a numerator. If you take pre-calculus or trigonometry, there's times when you're trying to simplify a trigonometric expression, like with a sine or a cosine or a tangent. And especially when you're looking at identity problems, you would need to use rationalizing the numerator at times. Okay, it's helpful. Not often, but it does come up. So to rationalize the numerator, we're going to do the same thing, except this time we're trying to remove the radical in the numerator. So I'm going to multiply the top and the bottom by the cubed root of. So I need to multiply by something that I can take the cube root of. I can't take the cube root of 2, but I can take the cube root of 8. So if I multiply 2 times 4, that's going to give me 8. And I can't take the cube root of x squared, but I can take the cube root of x to the third. So since I already have 2 x's here, if I add another x, now I'll have enough to pull out a group. So multiplying straight across, we get the cubed root of 8x to the third. Okay, I'm just applying my product property or product rule for radicals. And then in the denominator, I have the cubed root of 20xy. Okay, remember we're trying to remove the numerator this time. So the numerator should simplify to an expression without the radical. If you take the cubed root of 8, you get 2, and the cubed root of x cubed just gives us x. Okay, so the radical's gone. And now we're just going to divide by the cubed root of 20xy. In letter B, I have an expression that's a sum. So you have a square root plus 2. To remove it, what would I need to multiply by? Okay, I'm going to multiply by the conjugate, which is the square root of x minus 2 on the top and the bottom. And now I'm just going to multiply across. All I need to do is the first term squared. I apologize for my pen. Minus the second term squared. And then I'm going to have to distribute here. 5 times root x gives me 5 root x. And 5 times negative 2 is negative 10. And then if I simplify that further, the square root of x squared is just x. And squaring a 2 gives me a 4, so I have minus 4 here. And then in the denominator, I have 5 times the square root of x minus 10. And that would be your answer. If any of you have any questions, please feel free to reach out.